So I wanted to pop in and do just a few more really quick examples with you on how to simplify some more radicals. I'm going to do 2 videos in simplifying radicals. This is the first. The examples are a little bit easier, and then I'll do another video where we get a bit more complicated. So I'm just going to quickly go through a few more examples so that if you still aren't feeling comfortable with it, hopefully you'll feel a bit more comfortable after this video. So let's get started. Let's take a peek at what we've got. There we go. Okay, so my first example that I want to look at is, whoops, this right here. And you know what? I am going to make that a lot thicker so you guys can see it better. Okay, let's get started. So I would like to look at the square root of 16x squared. Okay. Now, in my previous video, right, where I talk about that definition and how square roots and exponents undo each other, if this were a quantity squared, then I could just go, ooh, they cancel out, boom, the answer must be 16x, right? Or I should say 16 times the absolute value of x, right? Because we talked about those principal square roots. But this problem is actually a little bit different than that. I don't have that quantity around here, so I can't just cancel those things out. I need to figure out what I multiplied together twice, right? Same exact thing. What did I have 2 copies of? Remember, the index here is 2. It's that invisible 2 that we have in square roots. What did I multiply together 2 copies of to give me 16x squared? Okay, so that's where I'm at here. So I always say, you guys, that multiplication is the best operation you can get in algebra because it's so flexible. So I'm just going to put all my work here on the right side. I'm going to leave my problem right here on the left side so we know what we started with. So I am going to rewrite my problem, square root of 16x squared. And like I said, multiplication is really, really nice. In this problem, I'm simplifying. I'm simply asking you to simplify this. So I can break these things apart. I can say, oh, okay, well, let me break this apart to be the square root of 16 times the square root of x squared. Because I can, because multiplication is great. I can literally just break the radicals apart when I'm multiplying things together underneath a radical. I can break them apart separately. And let me move myself out of the way there so you can see it. So all I did was I broke 16x squared up, the square root of 16x squared into the square root of 16 times the square root of x squared, okay? That's what I've got so far. Well, now this just became a lot easier, right? If you're looking at this, you should be thinking, okay, great, because I know what the square root of 16 is. And from here on out, you guys, I'm only going to be concerned with the principal square root, okay? So I'm not really going to be using those absolute value signs. We're just going to assume that we are taking the principal square root here. So the square root of 16, the principal square root is 4, and the square root of x squared, x. And in this instance, now I can cancel them out. Like now that 2 and that radical are going to just cancel each other out and leave me with x, okay? The square root of x squared is just x, right? The square root, the radical, and the exponent are canceling each other out, undoing one another, which leaves me with 4x. And if I go back and check this, right, I want to check it. So that means I need to make sure that 4x squared, quantity squared, gives me back my original 16x squared. So quantity 4x squared is 4x times 4x. 4 times 4 is, keep doing that, 16, and x times x is x squared. So I did get back to my original 16x squared. Okay? So that's the first example I wanted to do for you guys, so you could sort of see how that played out, how I can use multiplication to break those things up, okay? So now let's look at another, Let's look at another really important example. What if I asked you, okay, what is the square root of, use this brush, what is the square root of 0? Well, guys, I'm basically asking you what two things did I, what did I take 2 copies of and multiply together to give me 0? Well, of course, it's 0. Remember, it has to be, when you have an exponent, it has to be the same thing that you're multiplying together. So the only thing that I can multiply together twice to give me 0 is 0. Okay? 0 squared is 0. Make sense? All right, so that one I just wanted to quickly point out because it's always important to talk about what 0 is up to, because 0 can be crazy. 0 can be just wacky. Okay, let's look at one other example here. What if I asked you to find me the square root of negative 25? All right. Interesting, right? That means I'm looking for some number that I squared to give me negative 25, right? The inverse operation of our radical here is an exponent, okay? So I'm looking for some number that I squared to give me negative 25. Well, I mean, you see 25 underneath a square root and you automatically think 5. So let's start with positive 5. So if I'm squaring positive 5, that means I have to take 5. I want 2 copies of positive 5. I'm just going to make this look a little better so that it's very clear that I'm squaring it. So I'm taking 2 copies of positive 5 and multiplying them together, right? So 5 times 5, well, that gives me 25, but I need negative 25. That's important. Okay, so that didn't work. So it's not positive 5. Well, the only other choice I have is negative 5. Okay, so let's see if negative 5 works. Remember, this exponent is telling me how many copies I need to multiply together. It's a copy maker, right? So I need to multiply together 2 copies of negative 5. What happens when I do that, you guys? Well, negative 5 times negative 5, those negatives are going to cancel out. And 5 times 5 gives me 25. So this is also yields positive 25. So that doesn't work. That means that there is no real solution to this problem, okay? When our index is 2, when we're taking a square root, and for that matter, when our index is even, you guys, if we had a 2, or if that were a 4 or a 6, anytime you have an even index, okay, you cannot have a negative under there. It just doesn't work, okay? So there's no real solution. All right, so those were the examples that I wanted to do with you guys today. I hope that they were somewhat helpful. Just to give you a peek into, as just a few different concepts that I didn't cover in my introduction video. Okay, so negatives under even roots, excuse me, and 0, what do we do with that? And what do we do if it's not a quantity being squared that we're taking a square root of? Okay, so I'm going to do another video that goes into some that are a bit more complicated than this. So be on the lookout. All right, bye guys.